Hello, students. Good afternoon.
Good afternoon, sir.
My voice is clear. Is audible?
Yes, sir, it's very
Screen,
audible.
yeah, very good. Screen is visible.
No, sir, it's a blank screen.
Yeah. Okay. Now, screen visible. Okay, good. So, students, we had discussed. Our discussion was continuing the last class, basically on NMR, nuclear magnetic resonance spectroscopy. What I have discussed with you, that I am revising again before starting another part. We had discussed that NMR is a instrumental technique which is basically used to characterize, to identify the carbon hydrogen skeleton or framework that is present into the any structure of molecule. So basically what you can say, by NMR we can ascertain that type as well as the position of the hydrogen and carbon, and basically it's functioning based on the magnetic property of atomic nuclei. And we had discussed also that when the low energy beam fall down on any molecule, then what happen, nucleus will rotate, and due to the rotations of the nucleus the magnetic field generate, and that magnet, due to this magnetic field, if we are applying the external magnet, then what happen, the spinning of the nucleus takes place, and spinning can be we can say uh, noted in terms of graphs and plots, in terms of chemical shift that we had discussed. We had also discussed number of frequencies that required radio frequency wave, that is starting from, I can say, 10 to the power 8 to 20 to the power 12 nanometer. So it's a larger wavelength and low energy. So that we had discussed in the last class. We had also discussed that NMR will be two type, HNMR and carbon 13 NMR, proton 1 NMR and carbon 13 NMR. And the spinning part that we had discussed. So this part that is we had discussed in last class. Now we are discussing about, also we had discussed about you can say uh, chemical shift. So we are or this the relaxation that we had discussed, the can say solvents used in NMR also we had discussed. Instrumentation part of NMR we had discussed, how many uh, part is required in the instrumentation part. And also we had discussed about the chemical shift, that is TMS, that is present into the up, you can say upfield or shielded field, and others are present in downfield and deshielded. And chemical shift that we have discussed, that shift in hertz divided by the can say spectroscopy frequency or radio frequency wave frequency field that we had applied in the megahertz, external magnetic field you can say. So that is we can determine in the form the chemical shift. Factor affecting chemical shift also we had discussed about that inductive effect, van der Waals force, and anisotropic effect, and for hydrogen bonding, all are, if, what are the basic fundamental, that if the electron availability increasing, then chemical shift will be in desilted, will be desilted. So the uh, chemical shift will be shifted into the downward shift, down shift or desilted. So that we had discussed in last class, that the greater the electronegativity, deshielding, as well as more delta value that we had discussed. Similarly, van der Waals force, bulky group repel, can say that electron cloud and de-shielding the protons. Anisotropics like double bond. So double bond, basically the uh, anisotropic anisotropy effect will be there, and anisotropy will be more than what happen. Nucleus will be de-shielded. That we had discussed in alkene as well. Hydrogen bonding also. Hydrogen bonding can be make de-shielding, and intramolecular does not show, but intermolecular. Intermolecular means one molecule if bind with another molecule, hydrogen bonding, then it can be a fact. So that we had discussed in previously about chemical shift. So now the chemical shift, numeric value of the chemical shift that we are discussing from the uh, now today's class. So let me know. I have revised the previous topic, means yesterday's topic that we have covered. Once again, let me confirm, please, that my voice is okay and you are audible and understandable. My lecture. Any doubt, anything you have, or do not have? Any students, please tell me.
Yes, sir, it is clear.
Oh, very nice. Thank you. So now, chemical shift. I have told you that chemical shift basically it's a value, and that chemical shift show about the positions of can say NMR peak, where that is maybe away from the TMS, that is called as de-shielded. So the chemical value, the numeric value of the KMS, how we can determine. So basically the chemical shift is measured in ppm, part per million, and absorption normally occur in downfield of the TMS. So the can say always absorption, NMR absorption will be a chemical shift will be away from the TMS, will be de-shielded. Okay. So now interpreting the proton NMR spectra, interpreting proton NMR means what do you mean that how we can interpret the proton NMR? We have a proton NMR, how we can interpret it? कैसे हम इसको किसी भी स्ट्रक्चर में कैसे हम ascertain कर सकते हैं कि that is the structure of the molecule. So that is called as the interpretation part of the NMR spectra. So thing is that it's very important part. We had discussed about the chemical shift. Now it's the application part of the chemical shift. Then we will still discuss about the splitting part as well as, and we will study about some spectra of NMR. So students, look at here that each different types of hydrogen gives a peak or group of the multiple peaks. Means each proton will give a peak, a different peak. Maybe a single peak or maybe a multiple group of the peak. First thing. Secondly, the chemical shift that is determined, that is you can say denoted in delta and measured in part per million, ppm, in ppm, delta ppm, that is written in the bracket. You look at here, gives a clue as to the type of the hydrogen generating the peaks. It means it shows about that the hydrogen that is present in any functional group or any part of the any structure of the molecule, like alkane, alkene, benzene, aldehyde, whatever may be. So where the hydrogen is present and what is their absorption, that will be shown in the form of the chemical shift. So we have to find out chemical shift, positions of the chemical shift, where it is missed. We have to find out the value of the delta of the particular proton. So if, say for example, if a molecule have two types of proton or three types of different proton, then it will give three or two different absorption peaks. Third point, the integral gives the relative number of the each types of hydrogen. So I have told you that each types of hydrogen will give different types of absorption peak. Another thing, the spin splitting. Spin splitting, what is the meaning of that? We will discuss later on. It gives the number of the hydrogens on adjacent carbon. Means in same carbon, how many types of hydrogens are the similar types of hydrogen are present. अगर किसी नेबरिंग कार्बन पे कितने सिमिलर टाइप के प्रोटोन प्रेजेंट हैं, एक ही टाइप के, जैसे मिथाइल ग्रुप है तो 3 हाइड्रोजन सेम टाइप के हो गए, तो ये 3 टाइप के हाइड्रोजन हैं, ये किसी दूसरे, जैसे हम कहते हैं कि प्रोपाइल ग्रुप है, प्रोपेन है, प्रोपेन, प्रोपेन में आप जानते हैं CH3 CH2 CH3, तो CH2 पे जो 2 CH3 ग्रुप जुड़े हुए हैं, 6 कार्बन हो, 6 प्रोटोन हो गए, 3 जो है आपके मिथाइल ग्रुप के, 3 दूसरे मिथाइल ग्रुप के, तो दोनों के 6 प्रोटोन हैं, वो CH2 जो ग्रुप है मिथाइलिन ग्रुप, उसके ऊपर क्या इंपैक्ट डालते हैं, दैट इज डिटरमाइंड, दैट इज शोन बाय द स्पिन स्पिन स्प्लिटिंग। तो ये जो 6 हाइड्रोजन प्रोटोन है, वो 2 जो मिथाइलिन ग्रुप के 2 प्रोटोन है, उन पे क्या इफेक्ट डालेंगे, इसको हम डिस्कस करेंगे, स्पिन स्पिन स्प्लिटिंग। Next, the coupling constant. Coupling constant, what is this? It gives the information about the arrangement of the atoms involved. So coupling constant especially tell us about what types of arrangement of the protons in the molecule. So 3 important things that we have to be identified. Chemical shift we have to be identified in any spectra. Then spin splitting we have to identify, and coupling constant we have to be identified. So these 3 we have to be searched. Look at here. So we are looking in these types of hydrogens and position of signals. These are written over here. I am explaining with you by taking an example how the down tilting and up tilting takes place. This point, I think students, you understood about the things, that up tilting means, upfilled means, or shield means shield or upshield, or you can say shielding. It means absorption takes place towards TMS. So delta value will be lesser, as well as downfield or upward field. It means absorptions, NMR absorptions will be away from, you can say, TMS. So that we are discussing here. Look at students. This is basically NMR spectra. You know, ppm 0, where is the TMS is there, TMS is calibrated peak, is the PMS, and 1 2 3 4, this is downward field, this is the highest high field. There is you can say TMS has highest high field, and away from this is the downfield, so downfield or deshielded. Okay, and this shows the intensity of the absorptions. Intensity of absorptions means absorption peak, that much of intense, जितना ये ऊंचा जो इमारत होगी ये आपकी, उतना ही क्या कहते हैं, सेम टाइप्स ऑफ प्रोटॉन्स वहां पे प्रेजेंट हैं. दैट वी विल लुक इन इंटरप्रिटेशन पार्ट later on. Okay, so that we had discussed about numeric value of this. Okay, and chemical shift. Okay, so students, look at here, one example you are taking. You know TMS, tetramethylsilane. So this methyl group should be here basically. This tetramethyl means, sorry, this methyl group is not away, is not single. ये जो methyl group है, please this make consider it here. Means Si, silicon having 4 methyl group attached with the 4 methyl group, tetramethylsilane. Students, you getting the structure of, I think, tetramethylsilane. 4 methyl group हैं सिलेन, जो सिलिका के ऊपर, Si के ऊपर. So these are highly shielded proton appear in the field. You can say one methyl group having 3 hydrogen, so 4 methyl group having 12 hydrogen atoms. So 12 hydrogen atoms, highest shielded. No molecule will be there in universe that contain 12 protons in the similar types. एक ही टाइप के 12 प्रोटॉन किसी भी मॉलिक्यूल के पास नहीं हो सकते. 12 मॉलिक्यूल. Only the TMS is the only single molecule, single compound that contain 4 methyl group, means similar types of 12 hydrogen. Similar types of 12 hydrogen. Students, that's why it is most shielded, and shift that is takes place, always shift that is takes place in downward field. Okay, students, clear? Anyone can tell me first?
Yes, sir.
Yeah, very good. Thank you. So the tetramethylsilane that we have discussed, the structure of tetramethylsilane, the 4 methyl groups is attached with the silica Si, and all having the similar types of a chemical environment. You know, distance from silica Si, 4 carbon, is the same. So all chemical environment, electronic environment of all proton every proton have the similar chemical environment. So you can say 3333 12 proton have the similar chemical environment. That's why they will give only a single peak, red color in peak is longest peak, you can say, and that we will obtain because of 12 proton is there. So it they will be absorption peak will be the highest, and that highest one. And you can say highest shielded means tau value would be zero. No one molecule can be there will contain that type much of proton, similar types of proton in similar chemical environment. That's why every absorption peak will be away from the TMS in the downward field. So that we had discussed about the TMS as well, that the chemically inert, and it is it is used basically in as a in internal reference substance, basically you can say. So why? Because of reason is think that uh, chemically inert, miscible with the large solvent, 12 protons that are magnetically they are equivalent. Protons have the highly shielded, they give a strong peak in the small, in a even small quantity, very small quantity, it gives the very good result, very good peak, absorption peak. And it is a less electronegative than carbon. Definitely it is very important that silicon Si have less electronegativity than carbon. And it is the highly volatile, it can easily remove to get back simple, means it can be easily removed from the instrument. So these are the merits of TMS, tetramethylsilane. That's why it is considered as a internal standard. Internal standard, IS means internal standard. It is used as an internal standard for NMR spectroscopy. Students, I think you got the point of TMS, why TMS used as an internal standard in the NMR, because of that much of quality that I am putting here. Next, the chemical shift. I have discussed with you previously that the chemical shift can be measured into the ppm shift in hertz divided by a spectroscopy frequency in megahertz. And this division gives a number independent of the instrument used, because it is not depends on instrument. Basically, it is independent of the instrument used, means we have to determine the frequency of instrument only. Okay, and this is the tau, and this is the delta. So basically the tau relationship between the tau and delta, I have told you the delta value for the TMS will be the 0, and tau value will be the 10. Okay, so you can say relationship between the tau and delta, there is a tau is equal to 10 minus delta. Okay, so students remember it, the relation, the tau and delta both are, we can say, unit for chemical shift. But basically, primarily the delta is used because TMS having delta value 0. Okay, but the relation 10 minus delta is tau. So you can say, if anybody can ask you that tau value for TMS will be 10 and delta value will be 0. So that I think you got the point for the TMS only. So shielding and deshielding. I have told you what do you mean by the shielding and deshielding, that rotations of electrons to nearby nuclei generate the field that can either oppose or strong the field on the proton. So what happened? Uh, Electron, rotation of electron, basically that is present and that is nearby the nucleus, and or can say magnetic field that can either oppose or either we can say additive, strong the field. So that is called as, if there is if the magnetic field is opposed to applied magnetic field on the proton, then proton said shielded proton, means there is, if the opposing of the applied field, 12 types of similar types of proton in this tetramethylsilane TMS. So 12 proton, they are opposing the, to the applied magnetic field. Okay, so they are shielded, and if the field is strong, then the applied field, then proton feels high magnetic field strength, and such proton is called as deshielded. स्टूडेंट्स शील्डिंग और डिशील्डिंग का मतलब क्या है, एक बार थोड़ा सा मैं हिंदी में आपको बताता हूँ. शील्डिंग का मतलब है कि सिमिलर टाइप्स ऑफ प्रोटोन जो कि अप्लाइड, हमने देखा कि जो आपका एनएमआर इंस्ट्रूमेंट देखा, उसमें इंस्ट्रूमेंट में हमने क्या रखा, वी आर पुटिंग द सैंपल इन द सैंपल ट्यूब, एंड द सैंपल itself generate the, you can say, magnetic field, as well as there is the external magnetic field that is in gauge, basically 20,000, you can say gauge, you can say that we had discussed high gauge. and NMR is a proton NMR, the 60 to 100 megahertz, and carbon NMR 200 to 600 megahertz power of a radio frequency wave. So that much of external field frequency external field we are putting the sample. So two types of magnetic field is there. One is that sample having its own magnetic field. Another is the applied magnetic field, means external magnetic field. So what happens? The resultant magnetic field be there. So similar types of proton, like 12 proton in the TMS, so they oppose to the applied magnetic field. So what happens? Resultant magnetic field, so you can say it would be shielded. So applied magnetic field will be reduced. Okay, and but when mostly compounds that reduction the external magnetic field will be high because of the similar types of proton will be less. So that's why mostly protons they are deshielded, means their absorption NMR absorption will be away from the TMS. Students, are you getting my point? Shielding and deshielding you are getting? Anyone can tell me? It's very important. समझ में आया या मैं दोबारा रिवाइज करूं? Shielding and deshielding.
Yes, sir.
Okay, very good. Thank you. So the shielding proton seed the absorption signals to the right side upward field, and deshielded protons absorption signals to the left side with the downward field. I have told you previously that if there is a shielded the proton, then upward field means towards TMS, and deshielded means away in the left side means away from the TMS. You know, the right side there is the TMS that having the delta value is the zero. So the electronic environment surrounding proton tell us where the proton shows absorption in spectra. So very good, very important thing is that what is the electronic environment towards means around the proton, that is very important, and that may affect the NMR absorptions. Okay, so if you are increasing the magnetic field, we are increasing the say electronic field around proton, then what happen? It will create the magnetic field. So you look at your H, the He or H0. This is the HO. There is a spectroscopic field, means external magnetic field, and He, the magnetic field that is generated by due to the electrons. So that is present over here. So they are opposite directions. So although the electrons having very less electronegativity, means magnetic field, although the externally applied magnetic field is more high, so what happen? It is opposed only. It's and this opposite called as shielded to the proton. So H effect is the H0 means H0 means H effect is called as basically this difference is called as shielded. So the shielded proton that I have told you previously, that uh, magnetic field strength must be increased for a shielding proton to flip the same frequency. So we have to increase the magnetic field because of shielding protons oppose the magnetic field of applied magnetic field, basically you can say. Okay, so that we had discussed in previously about how we say these electronegativity, or you can say anisotropies, or can say hydrogen bonding, or they are affecting the chemical shift. That the same thing here. I'm not discussing again. Okay, so shielding. I think you got the point. This all. This is also we had discussed the factor effect and chemical shift, inductive effect, hybridizations, anisotropic effect, and hydrogen bonding. That I have told you. Look at here again, I am putting here the representative way, like electronic effect, like cx means cf, oh means these are the hydroxyl groups, or you can say functional groups. X means external groups, maybe the fluorine, oxygen, chlorine, bromine, iodine, hydrogen, and silica. So look at here, the electronegativity highest for the fluorine, and there is electronegativity decreasing from fluorine to the silica. Silicon having the lesser electronegativity than carbon also. Okay, so the chemical shift will be the highest for the fluorine, and lesser zero for the silica means tetramethyl silicon. So this is the TMS, and this is the deshielded basically, and most shielding one will be the CS3F. Okay, CS3 will be the most deshielded, means highest chemical shift. So that I have discussed with you, not going to again deshielding and highest part. Okay, so look at here, most shielded, we are increasing, if you are increasing the chlorine group. Look at in chloroform is highest desilted, highest chemical shift value, then dichloromethane, then chloromethane. So 3.05 ppm to 7.25. You are increasing the ppm because chemical shift. It means due to why chemical shift increasing because of electronegativity increase, because chlorine having the one chlorine group, two chlorine group, three chlorine atom. So highest three chlorine atom, highest electronegativity, and highest electronegativity, highest deshielding, highest chemical shift. So I think you got the point. Means electronegativity can increase the deshielding. So I'm not going again discussing repeatedly. We are discussing again the points that we are discussed again in the last class. Okay. So students, now we are discussing number of signals. So let me know uh, till now that we had discussed that much of part of the session of the chapter NMR. You got the point? Are you understandable? Or any doubt you have? First I can clear them, then I move towards. बताइए प्लीज अगर मुझे कोई चीज आपको समझ में नहीं आई तो, अदरवाइज हम आगे मूव करें.
सर क्लियर है.
Very nice. Thank you very much. The students don't have any hesitations. If you have any questions, any query from in your mind, and you have any hesitations to understand anything, you can ask me. I'm trying to speak in both languages, sometimes in English and Hindi, because I'm thinking that some students may not be able to understand, and there may be difficulty. But although it's very good, you are getting me. So the number of the signals means how many signals will be there, and that may depends basically three parameters. One is the we have to find out chemical shift. Where is the chemical shift? Then spin splitting. That is very important. Spin splitting we have to be find out. So in the given molecule, the proton will different environments to observe in different applied field distance, where the proton will identify identical magnet environment absorb the same magnetic field. Okay, so first thing is that the same types of proton will absorb the same types of can say will have the same type electron environment and will absorb the same NMR absorptions. A set of the proton have the identical environmental environments are known as the equivalent protons, while the protons with the different environment are called as non-equivalent protons. So number of the signals in a PMR means proton magnetic resonance, or NMR, HNMR. Spectrum tell us how many kinds of protons are present in a given molecules. So what you can say, NMR spectra tell us how many types of proton, how many types of hydrogen are there, how many types of single types of protons are there, what is the positions of the proton. So three things we can obtain, things we can obtain from the NMR spectra. We can predict the prediction of the different types of protons. So three things that we had discussed. So look at here, the students examples we are looking here, that ethyl chloride, ethyl chloride, CH3, CH2, Cl. So tell me how many types of proton, students. I will discuss one by one again, but any can students can tell me in methyl chloride how many types of protons are there?
2.
Two types of proton. And okay, very good, thank you. There is the two types of proton, means cs2 have two types of two proton, but they have the similar chemical environment. But cs3, they are the three proton, but they have similar types of chemical environment. Okay, so total there are the 5 proton, but type of proton is 2 and number of protons are 5, but one type of proton is 2, another type of protons are 3. Okay, so similar types of proton in methyl group is 3, and similar types of proton in methylene group it would be the 2. Okay, so if the substitutions on the methyl proton is takes place like Z, then the substitution of methylene proton, now the chemical environment in both the methylene protons are not equal to the methyl proton. So if you are putting the substitutions as a Z in methyl group or methylene group, then what happen? Now the chemical environment will change. then chemical, you can say, shift will be changed, because we are putting the group on the different positions, then chemical environment definitely will differ. So spectra, NMR spectra will be different from the ethyl chloride. Okay, so that is the point. Okay, now students, it's very important, it's clear for you, predictions of single NMR, number of NMR, you can say. Student, this is the structure, this is for your practice. Now you got the point about the NMR, NMR peaks, NMR absorption peaks, means how many peaks will be there, how many signal will be there. Can you ascertain me? Acetone, I am putting here in bracket also, but you can judge here that chemical environment of methyl group, two methyl groups are there in acetone, and the distance from of these methyl group from the carbonyl group, CO group, is the same. So the chemical environment for both methyl group is the same. So the all two methyl means three proton in one methyl group, three proton on another methyl group. So six proton have similar types of chemical environment. So they will show single peak. Getting my point, students?
Yes, sir.
Very good. Thank you. So look at here in benzene. You know the benzene having the six proton, and all six proton have similar chemical electronic environment. Why? Because of delocalization of pi electrons. Delocalization of pi electrons. So every proton, every carbon having the same chemical environment, and every proton will have same chemical environment. Okay, so these all six proton will show single absorptions, NMR absorptions only. Okay, although intensity of the peak will be high, because there are the similar types of proton is six. So what happen? The peak will be high, but absorption will be only a single peak. This is the paraxylene. Students, I am putting two methyl, two NMR signal. Can you tell me anyone why?
सर CH3 के प्रोटॉन्स जो है उनका अलग केमिकल एनवायरनमेंट हो गया, और
Uh-huh.
जो बेंजीन डायरेक्ट हाइड्रोजन्स लगे हैं वो
Definite. Yes. Very nice. Thank you. What is your name?
सर देवांगी.
Devangi. Very nice. Good, good beta. Very good. It's excellent. So students, look at you know, look, Devangi give the very good answer, because this benzene, the benzene having four protons, and the four protons have the similar chemical environment, all four. But that another the methyl group, the six proton that is present on the methyl group, both are the same position, means from the ortho and para position of benzene. So these six proton have different chemical environment. So one type of proton, four is the proton that is at एक टाइप का प्रोटॉन कौन सा हुआ जो बेंजीन पे डायरेक्टली जुड़ा है, फोर प्रोटॉन है वो सिंगल टाइप का प्रोटॉन हुए, और एक टाइप का प्रोटॉन कौन सा हुआ जो मिथाइल ग्रुप के दो मिथाइल ग्रुप के साथ जो छह प्रोटॉन जुड़े हैं. दीज आर द टू टाइप्स ऑफ प्रोटॉन्स. आई एम टेलिंग यू टू टाइप्स ऑफ प्रोटॉन्स. एक टाइप का प्रोटॉन कौन सा है जो मिथाइल जो बेंजीन ग्रुप पे डायरेक्टली जुड़ा है, अनदर टाइप का प्रोटॉन कौन सा है जो मिथाइल ग्रुप के ऊपर जुड़ा हुआ. सो वन टाइप प्रोटॉन्स आर number of protons are 4, and another types of proton number of protons are 6, 3 plus 3. Okay, so the two signals will be obtained. Now this is the methylene acetone acetate. Methylene acetate, students, there is an, you know, this methyl group that is near to the carbon or carbonyl carbon that have different chemical environment, and another methyl group that is joined with the means methyl group, means you can say ether group O. So what happened? One is joined with the O, another is joined with the carbon. So both have the different chemical environment. So the two NMR signal, two NMR peak will be there. Getting the point?
Yes, sir.
Very good. Thank you. This is the ethyl benzene. Students, I think you might now you can answer me. You can understand. Three. Are you getting me? Because the benzene having five proton, the five proton have the similar types of chemical environment. So one signal from the five proton, another one signal from the two methylene group CH2 group, and another from methyl group CH3 group. So 3 types of protons, okay, and 3 signal. Propane to all. Students, tell me.
Yes, sir. 3.
3 types. So one type of, कौन बता सकता है ये 3 सिग्नल किस किस के कारण है? Who can tell me?
Sir, OH, CH and CH3.
Very nice, very good.
Yes.
You are getting now. So this is the cyclopropane, and all are the same chemical environment, one signal. This is, student has let me know in this compound how many.
Sir, 2.
2 is okay. Methoxy, both methoxy have similar environment, and both
Yes.
CH2 group have same environment, okay.
Yes.
This
Sir.
2 signal, again in this, I think you got the point. Methyl group or methoxy group, 2 signal. Again, methyl group or methylene group, methylene chloride. Methylene chloride having 2 proton, means one type of proton, and methyl group having 3 types of proton, means 3 proton in single type. So 2 types of signal, 2 types of proton. Another, the 3 signals will be here again.
Yes, sir.
Agree? One type of proton, this methyl group, CH3 group that is attached with the carbon. Another is CH2 group that is joined with the oxygen and carbon. Another, the methyl group that is joined with the oxygen. So 3 types of signal. Okay. So students, now integrity of the peak, integrations under a peak, you can say determinations of area. So you can say how much, you can say strong of the, how much you can say width of the peak, means under area under the peak, that is show us the how many types, how many number of the protons of the same types of proton, you can say. Okay, so the area under curve is a peak is a proportional to the number of the peaks that generate the peaks. Getting the point? If the peak, you can say peak is high, or width, you can say under area curve of the peak is the will be more, it means similar types of proton will be the more. So look at here, students, this is an spectra, NMR spectra, that you can say. It's a compound, you know, you can say start from here, from 0, chemical shift will be 0, the tau will be 0, you can say, sorry, delta will be 0 for the TMS. Now deshielding takes place. So in this compound, first thing, let me know how many types of protons are there, how many types of peaks should be there.
Sir, 3.
Very good, very good. We have discussed previously, we have seen this compound previously. One types of proton in, that is the on benzene. 5 protons are there in benzene, so there are the one type of proton. Another types of proton, there is methyl group, CH2 group, that is 2 types of proton. And another last one, the methyl group, CH3 group, 3 protons, similar types of proton. Okay, now students, let me know tell me the chemical shift. Here is as a, can say chemical shift 2, another is 5, another at 4.2, sorry 7.2 ppm. 3 पीक हमें दिख रही है यहाँ पे, एक 2.1 पे, या 2 और 2.1 पे, एक आपको 5 पे, और दूसरा आपको 7.1 पे और 2 पे. So let me know, can you tell me which absorption peak for due to which types of proton? कौन सा पीक किसके कारण है? केमिकल शिफ्ट 2 पे है, 5 पे और 7 पे है. इन दोनों में सिर्फ तीनों में मुझे पीक बता सकते हैं कौन किसके कारण आ रहा है? अगर आप इसका आंसर दे सकते हैं, मींस यू गेटिंग द, यू अंडरस्टूड द एनएमआर. यस और नो?
सर जो 7.1 पे जो पीक है वो बेंजीन के हाइड्रोजन्स का होगा.
वेरी गुड.
और सर जो 5.1 में है सर सर वो CH2 वाले हाइड्रोजन्स का होगा, और CH3 वाला 2.1 पे होगा.
एक्सीलेंट. कैन यू टेल मी द रीजन?
सर डीशील्डिंग.
यस, डीशील्डिंग. वेरी गुड, थैंक यू. व्हाट इज योर नेम? आई फॉरगेट द नेम.
Pasha.
Vipasa, very nice, very nice.
Thank you, sir.
Students, yeah. Students, look at in benzene. I have told you, if the electron density will be high, electron availability will be high, proton will be desilted, more desilted. So the benzene having number of the pi electrons, okay, means 6 pi electrons are there. So benzene is most desilted. So the 7 or 7 to 10, you can say the desilting, okay, from the 7 to 10, the peaks will be there, absorption peak will be there. So and also the similar types of proton, एक ही टाइप के प्रोटॉन कितने हैं इसमें, 5 बेंजीन के अंदर, एक ही टाइप का प्रोटॉन 5 है. देखिए इसका पीक, देखिए इंटेंसिटी इज मोर अवे, बहुत बड़ा इंटेंसिटी है इसका. मीन्स एरिया अंडर कर्व इज बहुत बड़ा है. एरिया अंडर कर्व मतलब इसके पीक ज्यादा बड़ा है, तो ये इसका जो जो ये कर्व है उसका जो एरिया होगा वो कितना बड़ा, ज्यादा है. इट मीन्स द 5 प्रोटॉन्स आर देयर, 4 आर द सिमिलर टाइप्स ऑफ प्रोटॉन. एंड look at here at position number 2, the chemical shift. This is the methylene group and this is the methyl group. Methylene group CH2 ग्रुप है. CH2 ग्रुप में बेंजीन ग्रुप की तरफ एक इलेक्ट्रॉन कार्बन जुड़ा हुआ है, एक मिथॉक्सी ग्रुप के ऑक्सीजन ग्रुप के साथ जुड़ा हुआ है. दोनों ही इलेक्ट्रॉन रिच है स्टूडेंट्स, ऑक्सीजन भी और आपका बेंजीन भी, दोनों इलेक्ट्रॉन रिच है. दोनों ही मिथाइलिन ग्रुप को इलेक्ट्रॉन देंगे. ओके जब ये दोनों इलेक्ट्रॉन देंगे तो जो प्रोटॉन जिस पे हाइड्रो मिथाइलिन ग्रुप में जो प्रोटॉन है उन पे क्या होगा, अवेलेबिलिटी इलेक्ट्रॉन्स की बढ़ जाएगी. और इलेक्ट्रॉन की अवेलेबिलिटी बढ़ेगी तो क्या होगा, डिसिल्टिंग. ओके ऑल्दो बेंजीन से कम होगा बट डिसिल्टिंग होगा, इसलिए ये 5 के आसपास केमिकल शिफ्ट दे रहा है. ऐसे ही आपका मिथाइल ग्रुप जो है CH3 ग्रुप जो है वो कम अलग है. क्यों, क्योंकि यहाँ पे जो कार्बोनिल ग्रुप है वो इलेक्ट्रॉन डिफिशियंट होता है. कार्बोनिल ग्रुप का कार्बन इलेक्ट्रॉन डिफिशियंट होता है, इसके पास इलेक्ट्रॉन नहीं होता है स्टूडेंट्स. तो ये मिथाइल ग्रुप है वो इसको ये कार्बन इलेक्ट्रॉन नहीं दे सकता. तो ये मिथाइल ग्रुप जो है CH3 ग्रुप है, that having very minimum number of, you can say, electron availability, very minimum electron availability. So it will be upfilled, you can say. Shift will be up, you can say shielded, or you can say in upward direction, upfilled nearby TMS. So there is the absorption peak will be the 2. Okay, so students, you got the point. ये आपको स्पेक्ट्रा समझ में आया?
Yes, sir.
Very good. Okay, so this is the explanation that I have given you. I think no need to explain again. Okay. One thing more that we will discuss previously, I am discussing here only. That is about the splitting. What is the meaning of the splitting? Okay, back, we are going back. Students, यहाँ पे देखिए आपका यहाँ पे एक थोड़ा सा आपको डार्केस्ट चीजें दिख रही हैं. कहाँ पर, 7 पोजीशन पे जो बेंजीन का जो एब्जॉर्प्शन पीक है उसमें डार्कनेस है. ऐसे ही आपके यहाँ पे आगे पीक में सभी में इसमें भी डार्कनेस है. मिथाइलिन ग्रुप के जो 5 नंबर केमिकल शिफ्ट 5 पे है वहां पे भी डार्क है, और 2 पे भी है, वहां पे भी, वहां डार्कनेस नहीं है, एक सिंगल सा पीक दिख रहा है. तो इट मीन्स इसको बोलते हैं कि स्प्लिटिंग, जो पीक है वो स्प्लिट होता है. वाई, बिकॉज ऑफ नेबरिंग प्रोटोन. जैसे कि मिथाइल ग्रुप के पास, जो बेंजीन के पास जो नेबरिंग प्रोटोन है वो कौन है, और मिथाइल ग्रुप के पास नेबरिंग प्रोटोन कौन है, उसके साथ कौन है, उसके साथ इस हिसाब से ये डिस्कस होता है. ओके, सो वी विल डिस्कस अगेन. दिस इज द सिंपलेट, सिंगलेट, डबलेट, ट्रिपलेट, क्वाड्रेट. दीज आर द multiplet or shifting that we will discuss again. Okay, so let it go, we will discuss it again, what is the meaning of this. First we are discussing about the chemical shift first. Okay, student, first we will discuss, again we will come again. I want to discuss chemical shift first with you. Students, look at here. This is the spectra of aniline. One is M, another is OP, orthopara, meta. So this is peak, absorption peak for due to the meta. And meta, you know, 2 positions of meta in benzene, 2 more position of meta, 2 protons for meta, and 1 proton for para, and two proton for the ortho. You know, when in aniline, when the amino group is attached with the benzene group, then ortho and para proton or position have similar types of chemical environment, and meta position have similar types of chemical environment. You understood? So the proton that is present on the meta positions will have same type, will be the same types of proton, and protons that is present on the proton ortho and para will be same types of proton. And amino group, amino CH2 is away from, is nitrogen is there in between, so they are the separate proton, so they have the similar types of proton, same two protons are same types of proton, and they are shielded, and benzene protons are de-shielded. ओके स्टूडेंट्स, यहां तक समझ में आया आपको ये एक्सप्लेनेशन?
जी सर.
वेरी गुड.
Yes,
सो
sir.
look at here again that in the amino group, two protons are there, s2 group, and both protons, there is no any neighboring proton, कोई भी इसके पास में प्रोटॉन नहीं है. सो ओनली द सिंगल पीक, सिंगल एब्जॉर्प्शन पीक विल बी देयर एट पोजीशन नंबर 3.5 ऑलमोस्ट. केमिकल शिफ्ट 3.5 पे जो है ये एक ही पीक दे रहा है. विच वन? NH2 ग्रुप, मींस प्रोटॉन ड्यू टू द NH2 ग्रुप. Another, benzene having two types of proton, one is due to the ortho and para, another is the meta. So ortho and para, look at it, they are the splitting. ये बिखरा हुआ सा है, इसमें देखिए फिंगर लाइक प्रोजेक्शंस हैं, फिंगर लाइक प्रोजेक्शंस. ओके, सो ये होने को तो ये एक ही पीक है, बट इट इज स्प्लिटेड, ये स्प्लिटेड है. दैट्स व्हाई इट इज कॉल्ड एज स्पिन स्पिन स्प्लिटिंग. ये स्प्लिटेड क्यों हुआ? क्योंकि ये जो नेबरिंग प्रोटोन है, मतलब इस ऑर्थो पैरा के नेबरिंग कौन है? मेटा प्रोटोन. मेटा कितने प्रोटोन है? हाउ मेनी टाइप्स ऑफ मेटा प्रोटोन? देयर इज द टू प्रोटोन. ओके, सो दो प्रोटोन जो मेटा के पास में है, मेटा के जो दो प्रोटोन है, जो कि ऑर्थो और पैरा दोनों प्रोटोन के पास में मेटा के दो प्रोटोन है, तो ये दोनों प्रोटोन जो हैं वो ऑर्थो और पैरा दोनों के जो प्रोटोन हैं उनको इंड्यूस करते हैं और उनके एब्जॉर्प्शन को अफेक्ट करते हैं, और इसी को बोलते हैं स्प्लिटिंग. वो इसके स्पेक्ट्रा को स्प्लिट करते हैं. और स्प्लिटिंग इसलिए देखिए आप मेटा के पास, अब ये देखिए मेटा के कितने 2, अब इसको स्प्लिटिंग को निकालने का क्या तरीका है? n+1, n+1 हमेशा जो है स्प्लिटिंग इस तरीके से निकलती है, डिटरमाइन करते हैं. n प्लस क्या है? n क्या है? n है आपका नंबर ऑफ द प्रोटॉन्स. ओके, n+1, सो नंबर ऑफ द प्रोटॉन्स. तो आप देखिए ऑर्थो मेटा के पास नंबर ऑफ प्रोटॉन कितने हैं?
2.
यस 2. सो 2+1 3 स्प्लिटिंग, 3 स्प्लिटिंग होंगी. और ऑर्थो और पैरा के पास?
ऑर्थो के पास 2, पैरा के पास 1.
नहीं, ऑर्थो के टाइप, खुद के टाइप्स ऑफ प्रोटॉन नहीं पूछ रहा, नेबरिंग प्रोटॉन्स. आई एम आस्किंग नेबरिंग प्रोटॉन्स. हाउ मेनी नेबरिंग प्रोटॉन्स? ऑर्थो
सर,
ऑर्थो के पास एक होगा ना?
यस
सर टोटल, हाँ टोटल 2 है,
2.
सबके पास एक एक है. 2.
हाँ, पैरा पोजीशन, पैरा के नेबरिंग प्रोटॉन कितने हैं? 2. ऑर्थो के नेबरिंग प्रोटॉन के हैं? सिंगल. ठीक है.
यस सर.
हाँ, तो हमें क्या करना है, जो टाइप्स ऑफ प्रोटॉन, n कौन सा काउंट करना है? जो खुद का नंबर ऑफ प्रोटॉन्स है, सिमिलर टाइप्स ऑफ प्रोटॉन. बट सिमिलर टाइप्स ऑफ प्रोटॉन ऑर्थो और पैरा दोनों को मिला के, दोनों एक ही टाइप के प्रोटॉन है. ठीक है, एक ही टाइप के प्रोटॉन है. तो सिंगल टाइप के प्रोटॉन कितने हो गए? n = 3. गेटिंग माई पॉइंट? डोंट बी कंफ्यूज. ऑर्थो पैरा में टोटल सिमिलर केमिकल एनवायरमेंट के प्रोटॉन कितने हैं? स्टूडेंट्स रिप्लाई मी. हाउ मेनी टाइप्स ऑफ प्रोटॉन्स ऑफ सिंगुलर एनवायरमेंट, केमिकल एनवायरमेंट, सिंगुलर एनवायरमेंट होना चाहिए? कितने हैं
सर 2.
कैसे बेटा? ऑर्थो पे एक है
सर मतलब
दूसरे ऑर्थो पे एक है, पैरा पे एक है, 3 प्रोटॉन हो गए ना. 2 तो ऑर्थो हैं, एक पैरा है. 3 प्रोटॉन हो गए जो कि एक ही केमिकल एनवायरमेंट में है. यस
यस सर.
समझ गए? अब n+1, ये तो 3 तो क्या हो गए? n और +1. यस स्टूडेंट्स, अटेंडेंस का लिंक मैं डाल रहा हूं बेटा, अभी डाल देता हूं. ओके, आप लोग अटेंडेंस फीड कर सकते हैं, मैं लिंक डाल देता हूं. ओके, मिल गई स्टूडेंट्स आपको अटेंडेंस के लिए? आपको आई थिंक लिंक मिल गया?
नो सर,
नहीं मिला.
मैंने चैट बॉक्स में डाला है.
अभी नहीं आया है सर।
अच्छा,
नहीं आया सर।
जस्ट ए मिनट।
सर हमारी इसकी क्लास 2 बजे से होती है ना एडवांस।
अभी चेंज कर दिया है स्टूडेंट बेटा, इसका 3 से कर दिया है, वो शिफ्टिंग हो गई है ड्यू टू सम क्लासेस थे कुछ ऐसा, तो उसके कारण से शिफ्टिंग हो गया है।
ओके।
हाँ, जस्ट ए मिनट, मैंने चैट बॉक्स में डाला तो है, वो नहीं मिला। जस्ट ए मिनट। नॉइस मुझे फील कर रहा है। अभी आप मुझे बता सकते हैं प्लीज, लिंक आपको मिला या नहीं?
नो सर।
अभी नहीं आया है सर।
चैट बॉक्स में डाल रखा है मैंने, हाउ कैसे नहीं आ रहा?
सर दिक्कत हो तो आप मैनुअली भी लगा सकते हैं।
नहीं, वो बात तो है।
या फिर सर व्हाट्सएप पे सेंड कर दीजिए
हाँ,
ग्रुप में।
दैट वुड बी, बट ये है कि यहाँ पे मैंने चैट बॉक्स में डाला है, कैसे नहीं आ रहा? ओके, आई एम पुटिंग ऑन योर चैट बॉक्स इन व्हाट्सएप। ओके, आई थिंक इट वुड बी बेटर। स्टूडेंट्स, अभी देखा आपको मैंने व्हाट्सएप ग्रुप में डाला है, यू कैन सी देयर। मिल गया आपको?
सर सेशन ओवर आ रहा है।
सेशन
सेशन ही जो ओवर आ रहा है।
सेशन एरर बता रहा है।
सर एक बार
सेशन
टाइमिंग
ओवर
चेक
बता
कर
रहा है।
लो, सेशन ओवर आ रहा है।
ओके,
एक बार टाइमिंग चेक कर लो।
ओके ओके, 3 to 5 मैंने टाइमिंग डाला था उसमें। एनीवे, मैं इसको मैन्युअली पुट कर दूंगा, लेट्स सी इफ एनी प्रॉब्लम। हम एक स्क्रीनशॉट आपका अटेंडेंस का ले लें पहले, देन वी विल स्टार्ट अगेन। कैन यू पुट yourself as a, you can say, in video mode? Can you put? I can take a snapshot.
फिर वीडियो ऑन करना है।
हाँ, वीडियो में ऑन कर लीजिए प्लीज, जिससे थोड़ा सा स्नैपशॉट अच्छे से आएगा।
ओके।
यस।
करण वीडियो ऑन कर ले भाई।
ओके, ओके स्टूडेंट्स, थैंक यू। सो थोड़ा सा हम डिस्कशन पेंडिंग छोड़ दिया, उसको हम पूरा कर लेते हैं, देन we can bind up it. Okay, फिर हम नेक्स्ट क्लास में डिस्कस करेंगे. So students, we are discussing about in aniline basically two types of proton in benzene, that is on ortho and meta, and one on the you can say amino group which have the singular types of you can say two protons. So the single peak at 3.5. Ortho and para, there are the three protons. ये तीन प्रोटोन है, two ortho and one para. 3 plus 1 is 4. So 4 is splitting. 4 इसमें देखिए आप ortho para पे 4 splitting आ रहे हैं, means 4 finger like projections, 4 splitting. And meta having two protons, 1 and 1, 2 plus 1 3. So 3 projections, 1 2 3. Okay, so these are called as splitting. Okay, so n plus 1 we can determine the splitting. N is the number of the proton, number of the same chemical environment type, similar chemical environment protons, plus 1, that is called as splitting. स्टूडेंट समझ में आया आपको ये?
Yes, sir.
Okay, so I think ये आपका जो है काफ़ी लंबा समय हो जाएगा, और we can take again in another class about the splitting and all rest part we will discuss, I think, in next class. Okay, so students, now you tell me, you let me discuss with me about your problems and the things, because we had discussed. पूछिए आप लोग जो आपको पूछना है आज के सेशन में, इसके बाद नेक्स्ट सेशन में हम डिस्कस करेंगे. दिस इज ओपन सेशन टू यू.
सर हम स्प्लिटिंग में तो नेबरिंग प्रोटॉन्स को काउंट करते हैं ना?
इसमें स्प्लिटिंग में?
यस सर.
स्प्लिटिंग में हम नेबरिंग प्रोटॉन नहीं, हमारा जो चीज़ें हैं कि एन प्रोटॉन्स हैं, नंबर ऑफ द प्रोटॉन्स, नंबर ऑफ यस एंड द नंबर ऑफ द नेबरिंग प्रोटॉन प्लस 1.
यस सर.
नंबर ऑफ नेबरिंग प्रोटॉन प्लस 1.
तो सर जो वो एनिलीन वाला एग्जांपल था सर, उसमें फिर थोड़ा डाउट हो गया.
एक मिनट रुको, फिर हम इसको एक बार फिर से निकाल लेते हैं. अभी आपको ये पूरा हम एनवायरनमेंट पूरा डिस्कस करेंगे तो ये चीज़ें एकदम क्लियर हो जाएंगी. चलिए एक बार इसको फिर से देख लेते हैं, क्योंकि मैं सीधा ही एनिलीन पे आ गया. I think it will be back. I think we missed this aniline. You can look students here, I think again in meta you say nitrobenzene. आपको दिख रहा है ये स्क्रीन? Is it audible?
Yes, sir.
Yeah. In nitrobenzene, you can say again the nitro group is electron withdrawing group and deactivity group. Protons in the rings are desilting, moving the chemical shift downwards, and the magnetic the anisotrope cause the ortho positions to be the more diluted than the para positions or meta protons. ये देखिए इसमें आपका जानते हैं कि ऑर्थो पोजीशन जो है वो नाइट्रो ग्रुप के नज़दीक है, ऑर्थो 2 प्रोटॉन, और इनका केमिकल एनवायरनमेंट अलग होता है। 2 मेटा पोजीशन है, इनका केमिकल एनवायरनमेंट अलग होगा, और आपका पैरा पोजीशन का जो है जो केमिकल एनवायरनमेंट है वो डिफरेंट होगा। इसमें 3 टाइप के प्रोटॉन्स हो गए, 2 ऑर्थो पे, 2 मेटा पे और 1 पैरा पे, क्योंकि नाइट्रो ग्रुप जुड़ा है उससे ऑर्थो पैरा, जो पैरा का जो पोजीशन है वो डिफरेंट हो गया। हमने वहाँ पे जो डिस्कस किया था, यहाँ पे एमिनो ग्रुप था एनिलीन में, और एनिलीन में एक जो है 2 टाइप के प्रोटॉन थे, ऑर्थो, 2 ऑर्थो पे, 1 पैरा पे और 2 मेटा पे। हमारा पॉइंट क्या था कि ये जो ऑर्थो पोजीशन था, आपको जो प्रॉब्लम जहाँ आ रही होगी n+1 की प्रॉब्लम आ रही है। तो n क्या है? नंबर ऑफ नेबरिंग प्रोटॉन। ओके, तो आप देखिए इस जैसे मेटा की बात करें हम, मेटा पोजीशन का नेबरिंग प्रोटॉन कितने हो गए? 2 प्रोटॉन हो गए, एक आपके ऑर्थो पे और 1 पैरा पे, ठीक है। ऐसे ही 2 ये खुद के प्रोटॉन है, सो 2 जो क्या हो गया, अब 2 नेबरिंग प्रोटॉन 2 हो गए, तो 2+1 मींस 3। समझ पाए आप? मेटा पे,
यस सर,
मेटा के ऊपर जो है, मेटा के 2 नेबरिंग प्रोटॉन है, एक ऑर्थो एक पैरा, ठीक है। दूसरे मेटा के भी 2 नेबरिंग प्रोटॉन है, एक ऑर्थो एक पैरा, तो 2 नेबरिंग प्रोटॉन हुए, तो n+1 2+1 3, तो 3 स्प्लिटिंग वहां आ रहे थे, ठीक है। ऐसे ही आप देखेंगे यहाँ पे ऑर्थो पे, तो ऑर्थो पे क्या है, इस दोनों ऑर्थो पे एक जो है वो है क्या, नेबरिंग प्रोटॉन है, और दूसरे ऑर्थो कितने हैं, दूसरे पैरा पे कितने हैं, 2। आप समझ रहे हैं? ऑर्थो पे, दोनों ऑर्थो पे एक ही नेबरिंग प्रोटॉन है, और पैरा पे 2 नेबरिंग प्रोटॉन है, तो टोटल नंबर ऑफ नेबरिंग प्रोटॉन कितने हो गए, ऑर्थो और पैरा, क्योंकि दोनों सेम केमिकल एनवायरनमेंट के प्रोटॉन है, तो टोटल नंबर ऑफ प्रोटॉन कितने हो गए? 3 हो गए।
हाँ सर।
समझ में आया अब आपको? तो
Okay,
n+1 3+1,
Okay.
तो वहां पे क्या हुआ, 4 स्प्लिटिंग। आई थिंक एक्सप्लेनेशन में कुछ आपको कुछ डिफिकल्टी हुई होगी, अब शायद मुझे लग रहा है क्लियर हो गया होगा आपको।
हाँ सर, अब आ
Yes,
गया।
sir.
आ गया ना समझ में, कि हमें क्योंकि नंबर ऑफ नेबरिंग प्रोटॉन काउंट करने हैं, बट नेबरिंग प्रोटॉन ऑर्थो और पैरा को दोनों में जो प्रोटॉन है वो सिंगल टाइप के प्रोटॉन है, एक ही टाइप का प्रोटॉन है। ऑर्थो और पैरा दोनों को एक ही काउंट करेंगे, तो ऑर्थो और पैरा पे जितने भी नेबरिंग प्रोटॉन आएंगे सबको काउंट करेंगे। दोनों ऑर्थो पे तो क्या आ गए, एक प्रोटॉन आ गए, और पैरा पे क्या आ गए, 2 प्रोटॉन आ गए, तो टोटल नंबर ऑफ प्रोटॉन कितने हुए नेबरिंग, 3। ऐसे मेटा पे कितने हुए,
Okay, sir.
मेटा पे कितने हुए, दोनों मेटा पे 2 आ रहे हैं, ठीक है, तो वो क्या हो गए, 2, तो 2+1 3
2+1 3.
मेटा के लिए,
Yes,
एंड
sir.
3+1 पैरा के लिए, ऑर्थो पैरा के लिए।
Oh,
समझ में आ गया?
Okay, sir.
Okay, so rest part we
Yes,
will
sir.
complete, we will cover in the next class about the NMR, and I think in next class we will cover up about the NMR, and जैसे कि मैंने देखा आपका सिलेबस काफी पेंडिंग है, and we have to be take is in fast forward mode, and I think this मई में ही आपको कंप्लीट करना होगा हमें सिलेबस, so we will be try to complete or finish the syllabus, but definitely if any problem you have you can ask me, and we will be go in this same speed and same mode. Okay, although अभी जो आपका सिलेबस जो टाइम टेबल रिवाइज हुआ है, इसके अंदर मुझे अभी 2 आवर्स का टाइम दिया है, मीन्स 3 to 5. okay, so 1 hour I have completed. Shall we continue or we have to finish close here? What is your suggestion?
सर आज छोड़ दीजिए, कल से कंटिन्यू करेंगे, आज हम प्रिपेयर नहीं थे इस टाइम टेबल के लिए।
ठीक है, मैं भी समझता हूँ कि 2 घंटे का लेक्चर कंटिन्यू होना इज वेरी टफ एंड अंडरस्टैंड करना बहुत मुश्किल होता है, बट ये है कि टाइम टेबल में मुझे जो है स्लॉट में 3 to 5 में पुट कर दिया है, सो इट इज़ वेरी टफ, बट आई थिंक इसीलिए किया होगा क्योंकि सिलेबस काफ़ी पेंडिंग है और ये कवर करना है पूरा इंस्ट्रूमेंटल पार्ट एनालिसिस का, और ऑल्दो वी विल ट्राई वेरी गुड एंड वेरी गुड मैनर, ठीक है, अच्छे से हम ट्राई करेंगे, कोशिश करेंगे, और डेफिनेटली वी विल कवर अप। ओके, एंड लेकिन मेरा आपसे इंस्ट्रक्शन एक ही है कि स्टूडेंट्स आप अच्छे से मुझे इंटरेक्ट करें मेरे से, कोई भी डाउट हो मुझसे पूछ सकते हैं, पर्सनल फ़ोन से भी पूछ सकते हैं, ऐसे भी पूछ सकते हैं, एनी वे देयर इज नो एन इशू। ओके, आई विल बी विथ यू।
ओके सर, लीव कर दो।
हाँ जी, थैंक यू वेरी मच, यू कैन लीव नाउ।
Thank you, sir.
थैंक यू।